Hello, everybody, and welcome to Engineering Scale Models. I am Jason, your host, and I do models. How is everyone doing today? We are going to talk about a few different things. We're going to be working on a Nintendo Switch that needs a new P13 chip on it. It's the same one I worked on the last stream where I changed the M92 chip on it and the USB port. So we're going to break that back out and we're going to do some more work on that. But first I want to go over a few things that I have discovered on the Switch. We're doing some diagnostics with the oscilloscope and the meter and different diode readings and things like that. So let's bring up the overhead camera. So let's go in here and I'm all tangled up in my microphone here. Hold on. That's just crazy. So there's nobody here yet, so we'll give it a minute to see if anybody shows up to the stream. So alright, so we got that all tangled free. So okay, so I have here a couple of switches. Here is the one we worked on last time. Here, we'll put that there, but I want to discuss this one with you real quick. This is my good known working switch here. Everything works on this. I've already tested it. Everything works. I use it for testing the screen, and I'm using it to get different readings off of each of the chips in diode mode, all the various test points that are on the board. There's just tons of test points to measure to see if you're getting information and things like that. And some stuff was brought to my attention in another stream, the Coders live stream, that just about EMI filters and also the data lines that come from the USB port to the different various chips. So if you look at a USB port, let's bring up this one because I can explain it what I mean here. Just move these out of the way for a moment. So if I dump this camera and bring up this camera here. If I bring up this camera here and I show you this USB port here, hopefully y'all can see that. Alright. If you look here, the pins coming from the side here, the two outer pins are ground, and then you have a set of, if you use a diode mode reading, you have, starting from this side, you have ground, open line, and then you have 1, 2, 3, 4, 5 lines that will give you a diode reading. Then you have open line, and then ground again. Now, from what I can ascertain, the two outer ones, ground of course, and then you have power lines that are these open lines. I believe not power lines. They're data lines that read when connected to the dock or a charger for charger negotiation. And then you have this pin here, the fourth pin in on each side is going to be your power pins, where where they come in, they're going to give you a diode rating of about 0.467. So you have your power pins coming in, you have 2 power pins, and then you have your 4 lines in the middle. These are data pins to go to M92 and to go to P13. And also these open lines, I haven't located the exact location of where they go, but if we look on the back of the board here, if we take a look where that is, you have a couple of those pins that come from here. They shoot over to the battery management section of the circuit, and then you have the 2 pins that come into as inputs to P13. Then you have P13 outputting all the way into the GPU. But here are your 2 input pins, your 2 data pins for the charger. And as you can see, I believe this line has a pull-up resistor on it, and this line has a pull-down resistor on it. And we can test that. I've been messing around with data pins on here for a while with the oscilloscope, and I haven't released what I discovered yet. So if we come in here, let me grab my pin here and grab my ground, or the one I'm going to connect to ground. So if I take my red probe and I connect it to ground, and I put my meter into continuity or diode mode. If I put my meter in the diode mode and I turn my meter on, so we got the meter on, and if we go to, there we go, we got the meter. So if I take my black probe here, and I come in here and I come back to this P13 chip here, right here, that's your pull down resistor. Okay, so they're both pull down resistors. So they're going to pull these 2 ground until a signal from the you know what? I totally messed that up. Where are they at? That's your ground. This is a ground plane. This is your 2 pins that's a ground plane. No, that's not a ground plane. That's reading, that's giving me, I can't turn the beep off. The threshold voltage is set for 2 volts. I'll just turn the beeper off because it's not gonna beep now. So, now if I come back here, so if I look at this here, okay, so it's 0.9, 0.7. So yeah, these are pull-up resistors, and that could be a pull-down resistor. So we're doing that to these data lines right here. Now, if we follow these data lines, they're going to shoot over to the GPU. Okay, so yeah, they're going to go to the GPU unit. here. So that's not the 2 data lines I'm looking for. We have 3 unpopulated areas. And then let's go back over to the USB-C side here. And let's see what we have here. So we have our data lines. So we have our power here. So this pin and this pin are our power. And then we have these lines that go to the other side of the board. These are ground here. So they're going to the other side of the board, or they're going to an internal layer. So they're going to an internal layer, but I spent a lot of time doing this, and I've matched up these lines to 2 coming to M92 and 2 coming to P13. And the 2 coming to P13 also do deal with the output. There are 2-way lines that deal with the output from the P13 chip to the HDMI out on the USB-C cable to carry the HDMI signal to the dock. So that is the rundown of the type of analysis that I'm looking at, and I'm putting a file together that has all this information in it that I post to my Patreon page. There's no need to sign up. You can just go there and see the file. It's a Excel file. It has my parts list where I can get where all the links to all my parts, and then it has currently diode readings for 3 chips and the USB port, and then it will also have it'll also be adding test points and things like that to it here in the future. So we are gonna see. All right, so that was from a known good switch. Let's get here and talk about the one we're going to work on today. So this is the switch right here. I already changed M92 on it. Let's see here. We've already changed M92. It doesn't look too bad. No bridging. Did pop a resistor, but I was able to put it back. So that's M92. Now, when I go to plug the charger in, now when I plug the charger in, plug this charger in. If I plug it in, well, let's put a battery on it. This is my good known test battery. It has a label on it. It is a labeled test battery. So let's plug in our meter here. And we get this, it bumps up and then it's going to shut down and it's going to come back on with absolutely zero current flow. So, and then if I plug it in this way, it is completely dead and it does not work at all. So either I mucked up that port when I changed it in the last stream, or P13 is bad and I need to change it. And what I am going to do is I'm going to change P13. Well, we're going to see, because my granddaughter's here, and if she wakes up, I can't change P13. But we're going to try to get this done. So, alright. Okay, hold on a minute. I got a message here. Okay. Oh. Alright, guys. I have to go. Yeah, I have to get going. I have a message and I have a situation I need to deal with. I am going to have to end the stream here. I am sorry. I'm going to try to stream this at a later date. I am so sorry the stream had to end, but I have to go handle a situation. Thank you.